Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael, and in studio with me is Wenhao. Wenhao, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-4357, and everywhere else 1-866-636-6284. Our email is dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right. So, how are you today?
Good.
Feeling well?
Yeah.
All right, good. Where do you go to school and what grade are you in?
I go to Reagan Elementary, and I'm in 6th grade.
How is 6th grade?
It's pretty good.
Pretty good. Is there anything you'd like to see different with it?
Well, I mean, like, there's a whole quarantine and stuff.
Yeah, there's still that kind of stuff, right?
Yeah.
Where some kids still aren't at school and everybody's kind of getting back into the swing of things.
Yeah.
What are you looking most forward to when you go to junior high? Because you've probably been at Reagan for a couple of years now, right?
I mean, I'm pretty excited to, like, see junior high. It's been a long time since I've seen, like, a new campus.
Right. So you've been at Reagan since kindergarten, probably?
Yeah.
Okay. So you're looking forward to going on a new campus, having a couple of teachers, right, instead of just one? And
Yeah.
all right. Well, good. Well, always good to have something to look forward to. So in class right now, you're working on percents, correct?
Yeah.
Why don't you go over to the board, and we're going to talk a little bit about what you know about percents right now. So we'll discuss something real quick. What do you know about percents? Like, what does percent mean?
Well, percent is like, well, it's like a part of a whole value. Say, like, I have 100 marbles, 20% would be 20 marbles.
Okay,
So
so
it's
how would we write 20% just to show 20%?
Well, just a 20, and then the percent symbol is just a line between two zeros.
Okay, so that means you have 20 out of a possible 100,
Yeah.
which would be 20%.
Yeah.
If I had 40 marbles out of 200 marbles, would that still be 20%?
Yeah.
How do you know? Or
Well-
are you just guessing, or are you stuck?
Well, you can divide those by 2, and, like, so each 20 and 100. So
Right, so
20 out
you'd
of
still get
100.
20%, right?
Yeah.
So I just wanted to see if I doubled both values, if you caught on there, and you did. So I know one thing that a lot of students in 5th and 6th grade need to work on is they need to write values as percents, fractions, and decimals. So can you write 20% as a fraction for us?
20 out of 100.
And that's how you get 20%, right?
Yeah.
Because you have 20 hundredth, right?
Yeah.
20 out of 100.
Yeah.
And when you have a fraction like that, is there a way to simplify it?
Well, yeah, you can divide 20 by both sides, so that'd equal 1/5.
Okay. Instead of dividing both by 20, do you know another shortcut that you could do with the zeros?
Well, can't you, like, I remember one of my friends taught me 2 out of 10.
There
and
you
then
go.
turn that.
And it's the same thing, right? But now you're dealing with even smaller numbers, right?
Yeah.
And it's a little bit easier.
Yeah.
So if I had 20% written like that, then I had 20 over 100 as a fraction, how would I write that as a decimal?
Well,
And how would you read that?
well, that'd be 2/10.
Okay.
And
Can you simplify that, or do you need to leave it like that? That's kind of a trick question, right? Because the fraction we can simplify.
Yeah.
But the decimal, it has to be out of tenths, hundredths, thousandths, things like that, right? So we need to leave it like that.
Yeah.
All right. And you feel pretty comfortable using decimals and fractions and percents?
Yeah.
Excellent, because you're going to do some more of that today. All right?
Okay.
All right. All right. Nicely done. Well, we do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. Phone numbers are at the bottom of your screen periodically throughout the program. Time now for today's Math in the News. All right, in today's Math in the News, we are celebrating 20 years on Do the Math. That's longer than you've been alive, isn't it?
Yeah.
Yeah. All right, so we are celebrating 20 years this year, and as part of our celebration, we like to bring back some people that have been part of the program during the past 20 years. And one of those people is from way back when. And not to make her sound like she's long in the tooth, but Manja, how are you today?
I'm good, how are you?
I'm excellent, thank you. Now, Manja, do you remember when you were here with Do the Math? Because I remember when you were here, but do you remember what years they were?
Well, my first year of teaching was 2001, so my guess it was probably 2002 that I started on Do the Math.
Right, it was pretty early on. I know we were early on in the program, and you were here. And you were here for more than one season, or was it just one season?
I think it was actually 3.
Oh, okay. Well, there you go. I'm an old man. You know, things go by, right? All right? So you were here for 3 seasons. And how did you get involved? Because you, as a new teacher, you know, became involved with the program pretty early on in your career. How did you find out about it? How did you become involved with the program?
Well, someone in my district asked me, and we used to work in the same district, Michael and I, and someone just asked me if I was interested, and I started off being a phone tutor, and then one day they needed me to sub and go on TV, and then I got to do that quite often.
Yeah, and here's one clip of you right here. Do you remember this problem? I doubt you
No,
remember the
but
problem.
it does look like me.
Hey, your hair was a little longer.
17 fists on both sides.
And so what are some memories that you remember about being on air and being part of the program early on?
I remember enjoying it a lot. My students, I taught 8th grade at the time when I started, and my students didn't watch it as much, but it was fun to answer different questions online, and I think my grandparents probably enjoyed it the most, seeing their granddaughter on TV. And then when I moved to the Bay Area, I actually sent in a Do the Math video for part of my application process, and I think that helped me get hired.
So let's talk a little bit about where you are now. So where are you now?
I live in Redwood City, but I've been a teacher at Menlo Atherton High School since 2005.
Okay, and what are you teaching there?
I teach pre-calculus mostly right now, and I also have one section of geometry.
All right, and as an instructor, do you prefer one over the other, or it doesn't matter, or have you been doing the same thing for a while?
I've been doing pre-calculus a long time, and I prefer pre-calculus. Geometry I like, but it's not as concrete, and I feel like it's a little harder to teach. Where pre-calc or algebra, you can just say, okay, here's the steps. Where geometry, it's more like, okay, here's the tools, now let's look at it and figure it out. It's not as cut and dry.
Okay, well, speaking of cut and dry, some problems are a little more difficult, especially when kids phone in with things, and we're not totally sure what they want or what they need to do, especially if we can't see it. Let's take a look at this next clip.
1 and 1. So we have negative 17 fourths equals cancel, 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 x. So crosses the x-axis where x is negative 17 fourths and y is 0. Is that enough?
You tell me.
Okay, I think that's enough.
You know what? I don't know if the camera can do this, but if the camera in the middle, if it can get a shot of that whole board right now, and just take a look at all of that little x-axis intercept and everything that you just did.
Sorry,
I'm sure that if there was a kid calling, their head would be spinning right now.
So the kid's head would be spinning right now. Anyway, Boy, looking at that, all three of us together with Harlan there and you and I.
I know.
That's a long
And
time
you've been
ago.
on the show all these years. Good for you, sticking through it.
Yeah, that's right. I'm sticking through it. I've been here all 20 years and still going along with it. So do you have anything like this in the Bay Area that kids can use?
Not that I know of, but one thing I started doing during distance learning last year was I started using the Remind app. I don't know if you're familiar with that. And I have my students send me like a picture of the problem they're struggling on, and if they can show me their work, it helps. And then I can make them a little video on my iPad, and I send it back to them on how to do it. So that's one thing I started doing last year during the pandemic.
Well, that's great. I am familiar with the Remind app, and I know a lot of students are as well. Well, Manja, I know that you were truly an asset for us while we were here and do the math. There are a lot of tutors that come and go, as you know. People move on to do different things and greater things that you are doing right now, and we're certainly happy for you. You were able to make that move, and we're glad that Do the Math was able to help you be successful in that move to where you are now. And we truly appreciate all of your years with Do the Math and wish you nothing but the best from now on.
Thank you. I really enjoyed my time on the show, so this is fun to go back to memory lane.
Hey, you know what? Before I let you go, I know because you did, I know you were from Bakersfield. Did you grow up in Bakersfield?
I did. I went to Reagan Elementary and then Tevis Junior High and then Bakersfield High School.
All right. So before I let you go, is there anybody you want to send out a special hello to?
Maybe my former students at Bakersfield now have kids that are watching the show. Who knows?
Hey, you know what? That's true because I have run across adults and they go, "Well, you still do that math thing?" And I'm like, "Yeah, we're still doing it." And they're like, "Oh, my kid was watching it the other day and I thought that was you." So it's funny how this is going on to different generations. So anyway,
Yes,
Manja, thank you very much and nothing but the best from now on.
Okay, have a great day. Bye-bye.
Thank you. All right, that is today's Math in the News, one of our former tutors, Manja, and from way back when, 2001, 2002, 2003, celebrating our 20th season here on Do the Math. In studio, we have Wenhao, a 6th grade student from Ronald Reagan Elementary School. Looking forward to junior high next year, huh?
Yeah.
All right. Now, you have one instructor in 6th grade,
Yeah.
and you probably have homework every night?
Yeah.
Next year, do you know how many instructors you'll have?
No idea, but I know it's definitely more than one.
It's more than one. Probably like 6, I would imagine. I think that's what it is. So you're going to have 6 teachers wanting you to do stuff every single night. You looking forward to that?
No, not really.
Well, at least you have a good outlook on going and seeing a new campus and experiencing new things. And speaking of new things, there's always something new cooking at our favorite baker's place, Baker's Outpost.
It is time, once again, for a little math in the real world. We love those numbers, but we want to see how they actually affect us in real life, right? So today, we're at Baker's Outpost, and I can't express to you how wonderful it smells in here, but I'm letting you know that Laura Journey, the owner, is going to let us know a little bit more about this bakery. Laura, you own this place. What an amazing place. How in the heck did you start to be a professional baker?
It started years ago.
Okay.
From a very young age, my grandmother instilled in me that we should know how to bake and how to work our way around the kitchen. So from a very young age, I started with banana bread, which is what you're smelling today.
Oh,
I
it
made
smells
fresh
wonderful.
this morning.
Yeah.
Fast forward quite a few years, I met my now husband in Vancouver. When we came down here, there was very few options for bread.
Right.
I had previously gotten into sourdough baking before we left to move down to Bakersfield. After I had my kids, I was needing something to keep my hands a little more busy than just mothering, and so Baker's Outpost was born. And we saw a need that needed to be filled in the community, and we came across the Tehachapi Grain Project up in Tehachapi.
Okay.
And so we decided to take that and focus on whole grains and locally sourced goods, which is what our community and our county is a bounty for. So
Right. So, but tell me a little bit about the difference between, because I completely agree with you. We should know how to make our own food. We should know what goes into our food, right? And so what is the main difference? Again, very silly, basic question. What's the main difference between a loaf of bread that I buy in the store that's all wrapped up in plastic and all sliced up for me and something that you make? Because your product is really unique and better for us, right?
yeah. So what we are doing here is old world tradition. To me, it's honoring the ingredients. So we're taking locally grown grains, literally flour, water, and salt. So you've got 3 ingredients, and we like to say that we create magic with it.
No doubt.
Yeah, through the process of fermentation, you are left with a very highly digestible and nutrient-dense product. Whereas, of course, when you look at the back of a store-bought loaf of bread, there's about like 17 ingredients that you don't know what they are
I can't
and
even
why.
pronounce this one. Don't know what it does.
Yeah, why we're putting all these vitamins back into our food that we've stripped out. Using very just plain white flour. So what we're doing is just trying to create a very nutrient-dense and highly digestible. It's shelf-stable a lot longer than your average loaf of bread. And
Oh, that's super exciting. Okay, we're going to get into math in a little bit, but right before we do that, if you had one thing to bake, what would you bake? I mean, obviously banana bread's smelling real good, but what would be your choice?
For me, it would probably be rye bread.
Oh, really? Okay.
Yeah, the depth of flavor, the nutrient-dense aspect of it.
Yeah.
It's just hearty.
And it's a very unique taste, no doubt about that. Yeah.
Not everybody's cup of tea, but
Right.
we transformed a lot of people's mindsets
You
about
changed their
rye.
mind. Well done,
Yeah,
well done.
absolutely.
Okay, well, when we come back, we want to do a little bit of baker's math because I'm a math guy, certainly, but this math is a little different and really exciting and kind of fun. So we'll have to come back and do some baker's math in the bakery. In the meantime, I know there's some more problems to do back in the studio. Back to you, Mike.
Scott, also thank you to Laura, and I'm glad that Laura said she would like to bake rye bread. Rye bread, I was just telling John, is my favorite also. And Baker's Outpost, we certainly do love Baker's Outpost. And if you haven't had an opportunity to swing by there yet, if you're in Bakersfield, I know I usually don't do this, but they're at the corner of Truxton and Oak. So Baker's Outpost on the corner of Truxton and Oak. Look for Laura and all of the rest of them. And yeah, that's right, John. We love that stuff in our belly. That stuff, good stuff down there. I'll tell you, there's nothing wrong with any bakery, but that's our bakery down there. In studio, we have Wenhao, a 6th grade student from Reagan Elementary. And Wenhao is working on percent problems. So let's take a look at one of the problems you have for homework tonight. So the Alden Middle School girls soccer team won 80% of its games this season. If the team won 12 games, how many games did it play? Solve the problem using at least 2 different methods. Quite the problem you've got here.
Yeah.
All right. Well, you came to the right spot if you need a little bit of help, right? Yeah. All right, why don't you head on over to the board and let's take a look at the problem and you write down anything you think you're going to need to help solve this problem.
So we know that 80% is equivalent to 12. And so, well, what I just did was just 12 divided by 80%. What? Oops, I forgot to put the 80
Yeah, you can
there.
erase that little part if you need to. There you go.
So, and in decimal form, I like to, in school we like to divide with decimals. So I just convert that 80 to a decimal, and that's 8/10. So 12 divided by 8/10. And that would equal 15.
Now, how do you know that? I mean, you just do that in your head, or how do you, I mean, what do you do? How do you, because there are kids watching going, I don't even know what you're doing here.
Well, I mean, before, when I was doing the homework, I could divide it, but the 2 methods part, I don't know the second method.
Okay, so well, let's take a look at what you did first. You know that 80% is 12 games.
Yeah.
That makes sense. I think that most kids that aren't even doing percents would agree with that.
Yeah.
How do you go to 12 divided by 80% though? What's the thinking, and how do you know to do that step next? Like, is there a proportion or something you can set up, some ratios, or why do you do that?
I was taught about this one formula, and it was like A times B equals C. C being the part of the percentage, and so that's 12. And then A being the percent, and B being the total. So
Okay.
that's how I grew, that's how I was taught, but like I really have no clue on why.
Okay. And that's what we want to help you with, right? Because sometimes you're exactly correct in what you did. The answer is 15, okay? And they want you to do it 2 different ways, right? So you've done one way right here,
Right.
okay? So what we're going to do is we're going to just extend this a little bit, and you can still see what you've done, but we're going to leave you some room down here to do this another way now, all right? So here's what I suggest, all right? Head on over to the board, and let's set up a proportion, all right? So if I have 12 games, let's put 12 up there, and put a fraction bar under it. Now 12 is going to be what percent?
12 is going to be 80%.
So let's put 80% underneath. And we want that proportion to be equal to another proportion,
Yeah.
another ratio. We're going to set up a proportion, right, with 2 ratios. So put the equal sign between them. Now we know that we're trying to find the total number of games, correct? Mm-hmm. Now where would the total number of games go? On the top or the bottom?
Bottom?
Okay, why? Take a look at the first ratio you've got.
So
So we have games on top and percent on the bottom. So where would games go in the next fraction?
on top.
Okay, so put a bar, a fraction bar. And what variable would you like to use? What unknown? Like a lot of people use X or...
I'll just put X.
Okay, so put X at the top, because we don't know how many games there are yet, do we?
No.
But we want to know the total number of games. Now, if 12 games was 80%, what's the total percent we want to find out of?
So that'd be 100%.
There you go. All right? So now what I'm going to do is I'm going to have April come in and help you, and you two together are going to solve this problem. And if you don't see right away what to do, April can help you, possibly a little cross multiplying and dividing.
Okay, do me one favor really quickly. In fractions, we just write whole numbers. So if you can erase the percent and erase the percent, because we just want a number. We know that they represent percents,
Oh, let me get rid of that.
just the percent sign. Perfect. Okay, so like Mike said, these are equivalent fractions. So the fraction on the left of the equal sign equals the same value as the fraction on the right.
Yeah.
So what do you think we should do? Do you have any idea how we can approach this problem? What do
Well,
we know about it?
Maybe we should find out what makes this 80 100 and then apply that to the 12 and what equals to X.
That is definitely an option. So how can I get from 80 to 100
Well,
and then I can apply the same thing to the 12?
Well, you
right?
can just like plus 20 in order to.
So if you added 20, do you think that might be
Oh,
equivalent?
no.
Okay, so that's a great try. Thank you. That's one way to think about it. So let's go ahead and erase that. And then, so if we're figuring out, so I can't really figure out where that is, right? Have you used, well, we won't do tape diagrams. If I have equal fractions, what I can do is I can find the cross product. Have you heard of the word cross product?
I've heard of it, but I don't think I completely understand.
Okay, so a cross product is when I multiply, what part of the fraction is this here?
This is like the percentage.
But do you know what part of the fraction is? What the
The denominator.
denominator. So I'm going to multiply the denominator times the numerator on the opposite side. So that's the cross product.
So-
And then I'll multiply the denominator times the numerator on the opposite side. Let me move this down just a little bit, excuse me. Okay, so we'll multiply the denominator times the numerator. So what is 12 times 100?
12 times 100, that'd be 1,200.
Okay, go ahead and write it. And then, since they're equivalent fractions, we're going to bring down the equal sign. So just write an equal sign. And then we're going to multiply 80 times x.
So,
The denominator times the numerator.
yeah. So I just put 80 times x.
Yes, or if you write 80 and then x right next to it,
Yeah.
it's the same representation. That means multiplication. I'm multiplying 80 times x. So now, have you solved one-step equations? Do you know how to find the value of x here?
No, not
Okay,
really.
so to solve this equation, if this is 80 times x, and I want to know what that value of x is, I can do the opposite. So what's the opposite of multiplication?
Division.
Division. So I can divide this side by 80, so go ahead and put a fraction bar
So
or division bar. Yeah, and we're going to divide that by 80.
80.
And in equations, we have to keep them balanced. So if I divide the right side by 80, what do I have to do to the left side?
Then you also have to divide that.
I have to divide that by 80 as well, because we have to balance our equation.
Yeah.
Alrighty. So what is 80 divided by 80?
That'd be 1.
That would be 1. And then we can put the x next to the 1.
1x.
Yeah, so let's erase that really quickly. And let's keep the equal sign in the same place. Let's bring it straight down.
All right.
All right. And now I have to simplify over here. So I have 1,200 divided by 80. How do you think, what do you know about that? How can we handle that?
Just like,
Now remember, use your zeros canceling out like you did before to make it
Alright.
easier.
so that'd be 120 over 80, and then let's see. I mean 8, 120 over 8, and let's see, can I simplify that? You know what, I should probably do it mentally. I mean like on here.
Okay.
That way I don't make a mistake. So 8 goes into that. 40, 15.
Alrighty. So then go ahead and put that here because that is the value of x.
So 15 equals x.
Is that the same answer you got before?
Yeah.
And there's your 2 ways.
Nicely done. There you go. There's, you know what? We could find 2 more ways to do it also. But you did satisfactory on that. You got your 2 different ways. For a great working problem right there, you've got yourself a meal courtesy of our friends at the Broken Yolk Cafe. So congratulations on that. All right, we do have phone tutors available until 5:30, but we do have another opportunity to go visit Laura and Scott at Baker's Outpost.
We are back with a little math in the wonderful smelling world. It's amazing here at Baker's Outpost, and we want to know a little bit more about Baker's math, because as amazing as math is, Baker's math is even more interesting. So Laura, take it away. What are we going to talk about here? Because I'm so curious about how this all goes down, because whatever math it takes to make this smell, this is what I want to know.
Yeah, so knowing Baker's math is wonderful because it helps you scale recipes. You can actually, once you grasp it, create your own recipes.
Okay.
Being able to scale up, scale down. You can go into, like last episode, we talked a lot about fractions,
Yeah.
taking things in half, doubling recipes. It's a very unique way to scale percentages from the total flour. Flour in Baker's math is always 100%.
Yeah, that's pretty
So-
important stuff. Okay.
Yeah, so any
Yeah.
recipe you have, your flour is always your constant 100%, and then you scale everything else in relation to that.
Okay.
So a few years ago, we touched a bit about percentages
Right.
to weights, and today we're going to take weights and figure out percentages.
Awesome. Can you give us an example? I'm
Yeah,
curious about how
absolutely.
this all goes down. All right.
So first, I'm going to show you calculating from percentages to weights.
Okay.
So here we're going to do percentages to weight. So in a standard, I'm going to do a standard sourdough recipe just
Okay.
because that's where my brain is usually
Sure.
at.
Oh, yeah.
So we've got our flour, which is at 100%. Hydration, H2O, water. I keep that at about 82%, which is considerably high. Your average store-bought bread sits at about 40 to 50%
Oh, okay.
hydration, maybe.
Right.
The levain, or the starter, which is what gives the bread the life, I keep that at roughly 20%, which that varies up and down throughout the seasons. It goes higher during the winter, lower during the summer, and then salt we keep at about 2%. So when we have these percentages and we figure out what we want everything at, I'll see how much dough do I need. So if I need 1,500 grams, which I will say this is the total dough weight.
Okay.
We're gonna go figuring out from that. So calculating weight of any ingredient, we can use the weight of the ingredient equals the percentage of the ingredient. Sorry, my spelling. Times the weight of the flour.
Oh, okay. I gotcha.
Over 100.
Okay.
So here we are saying that we need to figure out we're getting 1,500 grams total dough weight. We need to figure out the weights here. So the weight of the ingredients, which I just realized I'm going to need a calculator likely to do this.
No problem at all.
So the weight of the water, we're going to figure that out. So weight of water.
Okay.
You take that, so it's 82%, and we need to find. We're taking the 1,500 grams, the weight of the flour.
Okay.
And then we are doing that over 100, which is what I just realized. I don't actually know it's going to be like 1100.
No problem at all. So mathematically, we
something.
can just cancel out all these zeros, right? And really what we're doing is 82 times 15, and I just pulled that for you, and that's 1,230. So that's kind of what we're looking at right there.
So
and that's the amount of grams, right?
There you go. So we are figuring out the weight of the water.
The weight of the water.
Yeah,
That
so
totally
the weight
makes
of the
sense.
water, you're taking the percentage, multiplying it by the total amount of flour needed over 100.
And I like the way you explain this, because when I look at these percentages and I add them all up together, I go, wait a minute, we're at 204%, right?
Which is what the whole, when I touched upon it a few years ago, I think it was like, well, how do you have
great,
over
though.
200%?
This, to a mathematical person, goes, how can you have 204% of a loaf of bread? But what you've done here is wonderful, because now we're talking about the percent of overall and the percent of the weight of the dough, right? And this is how much water you're going to get. That makes sense to me, and I like the way you explain that. Well done.
So then we can go through it and plug it in each one. So if you're trying to figure out the weight of your levain here.
Sure. Let's say we're trying to do the salt, right? We could just do this, right? Yeah. Because instead of 82%, we'd have 2%, right? Yeah. These would cancel out, the zeros would cancel out, and 2 times 15 is 30. You'd have 30 grams of water, right? So that would work out pretty quickly.
Yes.
And we could find out the water, and then we could find out, of course, the flour. The flour would be a pretty easy one to do as well, because this would be 100, right? And that would be 100, and you'd have 1,500 grams of flour. So I like the way that you've done this with the percentages, and they make a lot more sense to me now.
Right.
Because the percentages in other problems don't always add up to 204%. Wow, how interesting. So and then if you wanted to adjust this, recipe to make, I don't know, 2 loaves of bread or 5 loaves of bread, you could multiply the percentages. Or multiply the total dough weight. Yeah, there you go.
You can have 1,200 grams of total dough weight, and then you would just take that and you just move all the numbers
So many
around.
ways to manipulate this.
Yeah, so it's great. So you really can just scale up and down to whatever your needs are, and it makes things a lot easier.
And as a baker, there's a little bit of experimentation in there, I'm sure. So you can try it one way, and if it's not quite what you want, you can try it a little different way.
Constantly tweaking, even just 1%, if your hydration or 0.5%, the levain will go up and down a couple of percent. The salt generally always stays about 2 to 2.2%.
Sure.
But yes, the hydration and the levain are those two ingredients that are constantly moving around.
Yeah.
And this is what we were touching on a few years ago for percentages to weight. And so now it'll be really fun to go taking weights and figuring out percentages.
We'll see if we can do that. When we come back, we want to see if we can go the opposite direction if we're not too distracted by the amazing smells here at the bakery. Back to you in the studio, Mike. I know there's some more math to do, but please don't forget to come back and see us.
Trust me, we will not forget about going back there. So we certainly do love Baker's Outpost. 636-4357 is the phone number. Phone tutors are available until 5:30 most Tuesdays and Wednesdays throughout the school year as we celebrate our 20th season this year. We've got April in studio and Wenhao, a 6th grader from Reagan. And here's another problem you'll be presented with later in the week. This is like a sneak preview for you right now. You ready?
Yeah.
All right, let's take a look at it together. An agent sells a property for $220,000. You think you need to write that on the board? Probably. Go ahead and write $220,000 on the board, because I'm sure you're going to need that at some point. The broker takes a commission of 3%. So maybe put 3% up there somewhere, just off on the side or something maybe. Out of which he receives 60%. So you're going to need 60% up there also.
Right.
So we want to know what the agent receives. So once again, they sell the property for $220,000.
Right.
The broker takes a commission of 3%, right? So they're taking 3% of that total. Then you're going to get a new total. And then out of that, you're going to take 60% of that. Does that make sense?
Yeah, so.
Well, hold on there, brother. You and April are going to work this out. So get over there and get working.
Come on over. Tell me what you're thinking.
So, well, first of all, we need to find 3% of 220,000 and then find 60% of that. But first, so 200,000,
So-
3%.
Are you going to do some mental math or are you going to do some calculations?
So 3% of it. Well, our total is 220,000 and we have 20%. So normally,
So if you were to calculate it, how would you set up your calculations?
well, normally if I would to calculate it, so wait, no, this is the total.
So this is what the
Oh,
house sold
right.
for, right? And when you sell a house, a broker makes a commission. And so from this house, they're going to make this much. How many dollars
Now-
is 3% of 220,000?
Yeah, now I remember. So
Okay.
220,000 times 0.3 or
Okay.
3/10.
There you go.
So 220,000.
Mr. Kushine, is there any way you can move it up?
Indeed, I can.
Okay.
So go ahead and put your times 0.03 like you want.
Oops, my hand touched it.
Yeah, so we're going 2%?
Well, now you've got 30%.
So
Wait,
is
no,
this-
that's a 3. It's just the little smudge right
So
there.
you've got the decimal point right
Yeah.
here. So is that 3% or is
Yeah,
that?
that's. Should I put a 0.3 right there?
So this is still, so if this
Oh wait,
is 3%.
0.03.
Yeah, there you go.
Yeah.
Okay,
Okay.
there you go.
All right,
job.
so 3, 0, 0, 0, 0, 6, 6. So 660,000, but I have those 2 decimals right there.
Okay.
So I move it right there. So my decimal point.
So how much does the broker make from the house sale?
6,600.
So then that's the commission,
Mm-hmm.
right? And if that's his commission, does he get all of it or does he get part of it?
He gets part of it, 60%.
60%. So now I have to find 60% of that amount. So what does that look like?
So same thing there. I just times it by 6/10. So 600 and times 6/10. Oops. So that'd be 0, 0, 36. Put the 3 up there, 36, 39. And I have that 1 decimal point, so it's right there.
And what does that represent?
That's 3,960
And what does that represent?
dollars. How much money he made?
Who made?
The agent.
Yes. So from the house sale, the agent will bring home $3,960. Great job.
Yeah, nicely done. Do you think that's a pretty good wage?
I guess.
Make $4,000, right? You sell a property, you make $4,000 on it?
Well, if that, I mean, like, it just depends on how many houses he sells.
Right, yeah. I mean, you can, let's say you sell a couple a day.
Well,
That's
yeah,
a big day.
Yeah, that's a good wage.
Yeah, it is. Let's say you even sell 1 a week.
That's
Right.
Still a pretty good wage.
Pretty good, right?
What
Yeah,
if
I
you
mean,
sell
you're not
one
doing
every
too
2
bad.
months?
Oh no, that's horrible.
Wenhao gonna be selling 1 an hour. Let's keep this train moving right here. All right, nicely done. And now I said, you know, would that be a good wage? Or have you given any thought as to what you might want to do when you become an adult, as far as a work or career or anything?
Yeah.
What? You mind telling us, or is it
Well,
kind of?
something like I've been really into computer science, so so really that's really my career. I'm just, you know, seeing which one has a better wage.
Oh, no, there you go. That's one thing to look at. And computer science, you're in 6th grade, so you're probably like 11 or 12 years old?
Yeah.
Okay, so another 10 years you'll be in the workforce, and possibly even sooner than that. When you're in high school, I'm sure you'll be able to get hired doing computer things if you're into it a lot and very knowledgeable about it. A lot of avenues to go into with computer science. And that's one thing that the ROC and CTEC works with, is students getting ready for careers. And today we're going to take a look at how they get students ready for firefighting.
People should join this program because it helps people with real life situations in this, and it shows them how what it really truly means to be a firefighter and what they can actually do, and they have experience later on in life and actually become something like this. And it gives them the opportunity to be able to choose whether they want to actually do something like this or not.
So the most important quality of a firefighter, honestly, is integrity. We need to be able to do things when we don't want to do them, on the days that we don't want to get up, we don't want to put on all our gear, go out to a fire, stuff like that. We want to be able to get up, do our work, and do it right every single time, regardless of how we feel in the morning, what the weather conditions are like. And that's why integrity is the most important part of being a firefighter.
The best options about this program is it gives them experience. It gives them the ability to actually put the gear on, actually do a lot of the maneuvers, and realize that it's a different game once you get all the extra gear and weight on you. It kind of changes the whole dynamics of the class. I think the number one thing that people don't really expect is the physicality of the job. For the most part, you know, when you start adding 75 to 125 pounds worth of gear on and then having to do the work, that's where kind of things change a little bit. And once you get the opportunity to do that, it really is an eye-opening experience. I was kind of bored sitting around home. I had taught a little bit last year, or the year prior, I should say, and then COVID shut down. And so last year was my first full year of teaching. Everything was done through distant learning. So the question is how do you teach a firefighting class over distant learning? And so I'm super excited to have the opportunity to actually get back into the classrooms, have kids do a lot of the maneuvers, a lot of the drills. And so just seeing how they express themselves when they actually are able to complete a drill is pretty rewarding. I love that portion of the class. The drill that we just completed today is called the stress test. And you know, we completely black out the room. We have loud music to kind of distract them a little bit. They have to do this maze with the mask on. Of course, their mask is covered. It's totally blacked out. They can't see anything in the room. And so that's kind of super stressful at times. And then we start working, you know, a lot of the manipulative stuff, you know, with hose pulling and putting ladders up and confined space rescue and low angle rescue, using all of the rope systems, lots of stuff like that throughout the year. So what we did today, I was really proud of a lot of my students, or all of my students, that nobody stopped in the middle of the drill. Everybody was able to complete the drill, which is rare. There's a lot of people who aren't able to do that. And everything, if you think about it, what we did today is just crawling. You've been crawling since you were 8 months old, right? And so everything is between the ears. And so that's where the mind game starts coming in, because you're losing a lot of your senses. You know, you can't hear, you can't see, you can't feel anything because you've got the gloves on. You're crawling in tight spaces. That kind of overwhelms a lot of students, and everybody in the class was able to finish today. Some of these kids smell like goats, man.
And once again, thank you to all the staff and students over at ROC and CTEC. And we are, you can see right here, we've got one of the stickers. We are a proud partner of all of those students and staff over there. They have done some outstanding work so far this year. And every single week, better and better, all of the things that they're doing and producing and sending our way. Those videos that you're viewing are entirely done by the students at ROC and CTEC. They have 100% hit this thing out of the ballpark and are doing an outstanding work every single week. So we certainly do appreciate being a partner with them. We do have phone tutors available until 5:30 this afternoon. We are celebrating our 20th season of Do the Math this year. And that's pretty remarkable, don't you think? 20 years of doing this? Yeah. You'd think I'd be done doing this by now, don't you think?
Yeah.
Pretty soon, a couple more years we'll go. All right. Wenhao is a 6th grade student from Reagan Elementary and working on percents. So we've got a few more problems you're working on. So let's take it the screen together and you and April can work on number 1. So number 1, what is 15% of 60? So go ahead and you know what? Let me, do you want that other page, April?
No, not yet, because
Okay.
we can wait till we get to the grids.
All right, so let's go ahead and I'll just keep extending this one. So you guys can work right here on this one. So 15% of 60.
So talk to
Well,
me about that process.
For me, when I did the homework, I tried to, I have a 10 by 10 model right here.
Oh, well, then let's do that. Hold on just a second. We can go ahead and go
You
to the
wanna go
second
back? All
page.
right, let's
Yeah,
take a look,
'cause
see if I can,
He wants to use a 10 by 10 model.
get to
and
this.
I already pulled one up for you.
All right, so basically I have this 10 by 10 model, and well, I thought of this, this 10 by 10 model has 100 squares, so basically that represents 100%.
Okay.
And
So-
we know its total value is 60.
Keep going. I'm just going to find the right size here
Okay.
for you here. And,
All right. So now I'm trying to find what each block is representing, and that way I can figure out, and then later I can times it by 15. So, so since we have 15%, and its total is 60, and since we have 100 blocks, 60 divided by 100, that'd be 6/10. So we know each block is equivalent to 6/10.
Very nice.
And then I times 6/10 by 15, since, well, each block represents 1%. So 6/10 times 15, let's do there, 6 right there, so 30, 6, and then 9. So, and then
So it's 6/10, right?
Yeah.
Can you put a decimal right there for me, please? Okay. And so what does 9 represent? 9
that
is?
means that 9 is like, who is there again?
So
I think
what
we
is
wanna know.
15% of 60?
Oh yeah, that's 9. Wait, I feel like I did something wrong there.
Well, think for a second. I'm glad you thought of this. All right? Okay?
Let's use my non-school thing. So 60
Your non-school
times,
thing? All right, cool. Do that.
Times 15 as a decimal.
Okay.
And so 0, 30, put a 0 there, 0 there, 6. So that'd be 900. And then since I have 2, it's 9 again.
It's 9 again. That's amazing, isn't it?
And
So-
you just found 2 different ways.
Wenhao, here's what I want you to think about. Okay? Let's say you have 60. What is 10% of 60?
10% of 60, so
It's 1/10, right?
yeah, so you divide by 10.
So
then
60
6.
divided by 10 is?
6.
So you know that 10% is 6.
Yeah.
And you want 15%, so it's going to be a little more than 6, isn't it?
Yeah.
Is 9 a little more than 6?
Yeah.
Now here's another way to think about it. You need 5 more percent. Instead of 10%, you want 15%.
Yeah.
Now if 10% was 6,
Then
5% is half of that.
Yeah.
So what's half of 6?
3.
So 6 and 3 is?
9.
There you go. There's another way to do it. You just
There it
proved
is.
to yourself thinking about it reasonably and justifying what you did. So it amazed you twice, didn't it?
Yeah.
You came up with that. Nicely done. All right.
Way
Well,
to
you know
reason
what,
through
young
that. You
man?
did a great job.
Let's take a look at number 2.
All right.
If 40% of a number is 56, what's the original number?
Well, Let's go back here. This one, I just did my own little thing. So since 40% is 56, 40% times 2 to make it 80%. So that'd be 56 times 2, so that'd be 112. So 46, or 56, sorry.
56.
That'd be 112. And since 80% is 56, and since we need to do 20 more, then we just, do 80% divided by 2. Oh wait, it's 40%. 40% divided by 2, that'd be 20%. So 56 divided by 2, that'd be 28. So I add 28 to that. So 3 and so 1. So that'd be 140.
All right, so let's take a look at what we're doing here.
Yeah,
Okay.
let's write something
Because
down.
you got a lot of stuff going on, right? Which is cool to see, and I appreciate that you're doing that. But there are some kids at home probably going, all right, I see what he did and I heard it, but I don't quite get it. So let's take a look at the problem again. If 40% of a number is 56, what is the original number? So you know the number has to be at least twice that number, right?
Yeah.
Which is what you did. So you said twice of 56 is 112.
Yeah.
Right? And then you went on from that to get your other 20%. So April's going to work with you. You guys have a minute to work on this to make sure that your number is correct.
56.
So we got to 80%, right?
Yeah. So
And then you said we needed
20%.
20%, so we did 40%.
Divided
and
by
then we
2.
divided by 2, or 20%.
Yeah, and then at
And
the
then
same
we took
time,
56
we also divide
and
that.
divided by 2 and got 28, right?
Mhm.
I'm doing it in my head, hold on.
Yes, that's
Okay.
correct.
28, so that's 20%. So I took my 20% and added it to
112.
112, and then you got 140. And so since we had 40% is 56, we needed the 100%, and we got to 140.
There you go. So I just wanted you guys to kind of work it out a little bit right there so that kids that were hearing that going, whoa, that's pretty rapid fire movement there. It made sense, but then you can see it also. Well, you know what? We do have one more opportunity to head on out, visit with Laura and Scott at Baker's Outpost. Scott?
Hey, we're back to some math in the real world, and there's a little bit more. No, there's actually a lot more math to do here at Baker's Outpost, so we are looking forward to. Now we have to go the reverse direction of where we went last time. Laura, take it away. I'm excited about this one. Here we go.
So this is the exciting little bit of a reverse from what we were just doing, the percentages to weight.
So we're going weight to percentages now.
Yeah,
Okay,
so
let's
if
do
you
it.
see a recipe with weight,
Yeah.
we're going to show you and give you some formulas to figure out the percentages of each ingredient.
Sure.
So I'm just going to give you a recipe here. We're going to say 423 grams of bread flour and 106 grams of, let's say, just an all-purpose flour.
Oh, okay.
That's our abbreviation.
So you've already measured out these things, and we want to
here.
know the percentages of the
Yeah,
overall.
yep. So 354 grams of water and 106 grams of leaven, which is starter,
Okay.
those kinds of things.
All
And this, we won't get into it today, hopefully next episode, but it actually will go further on calculating if your levain has a different hydration. If it's not at 100% water and flour, then it actually has a bit of a different calculation to go
Right.
about, because you have to take into consideration also the percentages in the levain.
Sure.
All right, so here we've got a bread recipe. Like I said, flour is always 100%. So we have 2 flours here. So
Right.
we need to add 423 and 106, which is 529.
Well done.
529 grams. So we know now we've got our flour weight. So the formula that we have is going to be the percentage of the ingredient equals 100 times the weight of the ingredient
Okay, yeah.
over the flour weight, which was 529
Oh, I gotcha.
grams
Okay.
there.
So before we had the 100 on the bottom, and this was on the
Mhm.
top, and it makes sense because we're going the opposite direction now.
Yeah.
Yeah, there you go. All right.
So if we want to plug all that in, so to find out the percentage of the ingredient, you're going to take 100 times the weight of the ingredient. So we are going to figure out, let's do the water.
Okay.
Percentage of the water
Yeah.
equals 100 times the weight of the ingredient, which was
354.
354. And we're going to put that over 529, which leaves us with 67%.
It does list it at 67%. I gotcha.
There
Okay,
you
so
go.
there's your percentage of water, and if you needed to go back the other direction, you'd already have the percentage of water. Yeah,
Yeah.
there you go.
Yeah, and then we can go on using the exact same formula here. So if we have our salt here, the percentage of salt is equal to 100, and we're going to go back over to our weight, which was 11 grams.
All right, yeah.
Over 529 grams, and that leaves us with the 2.1% if we want to round up.
Yeah.
I believe that 7 pushes it up to a 1 there. And so there we go. There we can take each ingredient, weight, doesn't matter what it is, and we will find out the percentage in relation.
Right. And being able to go back and forth depending on which stage you are in baking is important, because you might know some variables on one side and need to go the other direction, or you might know how much weight of something you have here, you got to go back to the percentages. Either way, it's good to know both directions, and we always talk about that in math, especially when you're doing some, I don't know, maybe division problems. To check that problem, you want to do some multiplication, right?
Yeah.
When you're doing some division or some multiplication problems, to check it, you can do division. There's always a way to go back and forth in all the aspects of math.
Well, and the great thing too is that it will also show you the relation of each ingredient in, so you can automatically look at, you know, say a brioche dough that's going to be heavy, enriched with butter and eggs and milk and those kinds of things. So you can look at the amount of that and automatically know this is an enriched dough, not a sourdough, because it has all these additional ingredients into it.
Oh, look at that. Do the math. Look at that. We are so excited for you to share your talents and experience and excitement about baking with us once again. So, a do the math tile just for you. Thanks again for your time. Wow, I learned a lot. I think it was pretty cool. And you know we'll be back here again because there's a ton more math to do in the real world in general, but especially in the bakery place. And you know what? I love being outdoors, but the smell in here, again, I just can't get over that part. It smells wonderful in here. Good place to do it. Mike, back to the studio. We'll see you.
All right, thanks for that, Scott. Also, thank you to Laura. She's been a friend of the program for many years now, and we are very happy to see that she's got herself a permanent place on the corner of Truxton and Oak. And I'm just glad that tomorrow is Thursday because they're open, and hopefully they'll have some rye bread when I head down there. Anyway, Wenhao, yeah, there you go, cash register. It's going to cost me a couple of dollars for that, but well worth it. 6th grade student from Reagan. Did you learn anything today?
Well, yeah, I learned how to use a 10 by 10 model and to make, to find like the value of a percentage.
Good, so you learned a little something. Did you have fun?
Yeah.
That's the big thing right there. Hey, you know what? We have phone tutors until 5:30. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.